Morning, students. We are on the chapter triangle. Now four exercises we have done. The fifth exercise is pending, last exercise of the chapter. This is on depending on this exercise is depending on Pythagoras theorem. It is a very well-known theorem. But if I talk to you about its proof or its converse, both are not in the new syllabus. So we will see only the statement of the Pythagoras theorem. We will see the conclusion of this theorem. We will not see its proof. So proof is out of syllabus. So you all know about Pythagoras theorem, PGT, shortly called PGT, and in any right angle triangle, hypotenuse square is equal to sum of square of other two sides. Sum of square of other two sides. So this is a Pythagoras theorem, you know it. We just have to see some applications based on Pythagoras theorem. One of the question it is definitely come in the upcoming exam. So please do this particular exercise carefully. So I start with some example which are looking good here. Example number 13 is looking good. Let me explain that. Example number 13 we have picture we are given that BL and CM are medians. Look at the picture. It is given A, B, C. BL and CM are medians. You know medians meaning these are midpoints. And where for right angle triangle ABC, where A is a right angle which is given. What given we have? Triangle ABC is a right triangle with angle A90. CM and BL are medians. And the median meaning these two are midpoints. One should know M and L are midpoints of these two sides. To prove, what to prove? We have to prove 4 into BL square plus CM square is equal to 5BC square. That to show. Okay. Now look at students how we can go with this. Answer is looking good. I just tell you here three right angles are looking. The big one, the CMA small one, and BAL the third one. So I'll first take a big one. I start my answering here in triangle BAC by PGT Pythagoras theorem because it is 90 degree. So BC square hypotenuse equal to AB square and AB square plus AC square. This is the equation number 1 I left here. Now in triangle CAM, I'll take CAM which is also right angle triangle where hypotenuse is CM. So by PGT, what I write? CM square equal to CA square plus AM square. Now try to understand. After it, it's very important term I'm writing here. CM square equal to CA square plus AM square. This CM is same, CA is same, but this AM square, where AM is half of AB because AM is a midpoint. So instead of AM, I am writing half AB like that. And more I want to do, I'll take separate it and take an LCM. 4 will come here, 4 also will come here. Equation number 2. Afterward, I'll choose the third triangle BLA. LAB by PGT. Here if you look, this is a hypotenuse, these two are the sides. So BL square equal to ALAB. And instead of AL, I look L is a midpoint, so AL I will write AC by 2 plus AB square. I'll open it same as last. This is BL square equal to AC square by 4 plus AB square. Now I take the LCM, 4 will come here. 4AB square. Now what I'll do? I need the answer BL square plus CM square. I need the answer BL square plus CM square. So I'll add it. Add second and third. Look at, I tell you how we can get the answer. This 4CM plus 4BL is equal to, it is 4CA square plus 1CA will be 5CA square. And AB square plus 4AB will be 5AB square. Now I take 4 common from here and I take 5 common from here. So very good thing, but I can see 1. Can you see 1? AB square plus AC square equal to BC square. AB square plus AC square equal to BC square. So I'll remain it same. And this portion can be written BC square. So this is the particular answer what we were needed. So this was a simple question. Just working on the 3 different triangles. So how you manage? You please look for this question. Okay. Now I will go on the other example. The example number 14 I wish to tell you. Look at. O is any point inside a rectangle ABC. Please try to focus. This is a rectangle. And O is any point inside the rectangle. Suppose I take here O. I write here, it's given that ABCD is a rectangle and O is any point inside it. To show OB square OD square equal to OA square plus OC square. So okay, how will we manage? Look at it again. First we construct something to do this. We join this, join OA, OB, OC and OD, and one more construction we'll do. We will draw a line. PQ passes from O, which is parallel to AD. Draw PQ through O such that PQ parallel to AD. Now try to understand what I've done. We draw PQ parallel to AD. AD is already parallel to BC because it is rectangle. Automatically all three, this and this are parallel line. Automatically if you would have a 3 rectangle, downside first, because already it was parallel, it is also parallel. They were parallel, it is also parallel. You know, those opposite sides are parallel, it is going to be that parallel we can say, but at this time it is 90 degree, you know it is a rectangle. So we have 3 rectangle. I just again want to bring this in knowledge that this is the rectangle where this side and this side are equal. This side and this side are equal. This side and this side are equal. It's a rectangle. Now I'll go on my requirement OB square, OD and something like that. And slowly I just would come here the topic that is going to be 90 degree. This is 90 degree. This is 90 degree. One should know it is again a rectangle. So I'll write something here. Since PQ parallel AD parallel BC, definitely according to the question we have this angle 90 degree, this angle is also 90 degree. I write BPQC and APQD are rectangles, and I'm just focusing on the rectangle by two things. Actually, these should be 90 degree because in rectangle all angles are 90 degree, and these two sides are equal. This is also very important. Okay, I just mentioned it. These two equal, these two equal, these two equal. Okay, now I'll go on the all the triangles. You can understand I need OB square, I need OD square, I need OA square, I need OC square, and these are not. But you know, if you go on this right angle triangle, it's going to be hypotenuse. If you go on this right angle triangle, it's going to be hypotenuse. You know, so it's all of the hypotenuse. So definitely we'll use the Pythagoras theorem on each right angle triangle. Okay, in triangle OPT, OB square equal to OP square plus BP square. 1. I'll go on OD, meaning I'll just go on OQD. In OQD, I have a OD square equal to OQ and DQ. Again, I'll go on OAP, OPA. I'll have OA square equal to OP square plus AP square. And the last triangle, it's a OQC. By PGT, I have OC square equal to OQ square plus CQ square. Now, interesting thing has begun. 1, 2, 3, 4. We have 4 equations, and you can understand that OB square plus OD square I need in left hand side. So you can take left hand side, or you can add these two. So both have the same meaning, no matter at all. So add 1 and 2. Why? Because I need OB square plus OD square. You also can take left hand side. Do both have same meaning. Okay. So I have OB square plus OD square. Left to left I add, and right to right I'll add OP square plus BP square plus OQ square plus DQ square. This section we have got. You know, OP square plus BP square plus OQ square plus DQ square. Now I'll manage. I need OA square and OC square on right hand side. So I need OA square and OC square their side. OA square and OC square have a meaning this and this. So I'll manage that OP square plus AP square and OQ square plus CQ square I should get by anyhow. OP square I have already, look at OQ is already I have. Look at, I need AP square which is not there, I need CQ square which is not there. So in my opinion, you can see that BP is equal to CQ. BP is equal to CQ right here. Since BQ which is equal to CQ and AP is equal to DQ. So put both the values there. What do you get? OP square is same. BP square equal to, I have a BP, where BP is equal to CQ. BP is equal to, look at BP is equal to CQ. So BP is equal to, I'll write CQ. OQ is same. Instead of DQ, I'll write AP. Can you see? Now I'll again manage myself. That example, equation number 3 says OP square plus AP square. OP square plus OP square plus AP square. You can see AP square is here. So write them together. OQ square plus CQ square. OQ square plus CQ. I just manage it. First these two I've written in these two. Afterward I wrote there. And then afterward by 3rd and 4th, these two will be OA. And these two, it will be OC. So finally, this OB square plus OD square equal to OA square plus OC square, we have got our requirement. So this is nothing tough. 4 equations we get. Add 1 and 2, and the letter 2 will use afterward. But just take the help of these two equal, and I think you can get the answer easily. So this was the question. Example number 14 we have completed here. Now I move on the exercise, which some questions I can see they are good. So in the exercise 6.5, I have question number 2. PQR is a right angle triangle, where P is a right angle, Q you can write here, and P and M is any point on QR such that PM perpendicular to QR. Now it's very simple thing that triangle given, triangle QPR is a right triangle where angle P is equal to 90 degree and M is a point on QR such that PM perpendicular to QR. To show, what to show? It's a PM square equal to QM into MR. Before starting the question, let me tell you that question number 3rd, can you see the second of the question number 3rd? It's very same question of as question number 2, because only naming are changed. Here P, Q, R am used. In the question number 3rd, A, B, C and D are used. But let me tell you, question number 3rd, you can see second of the question number 3rd, prove that AC square equal to BC DC, which is looking same here. So I won't tell you question number, the second of the question number 3rd, which is your job to do is same, which I am going to tell you here. Look at this question is nothing hard. I can see here 3 right angle triangles, and I will take all. First, it's a big one. Second is this, and third is this. So, in right angle triangle, I start myself. I write in right angle triangle QPR by PGT. QR square is equal to QP square plus PR square. QP square plus PR square equal to QR square. That is first one. Now, I'll go on this triangle. In triangle PMR, first I should take a small one, no matter at all. Let me tell you one thing which I can see right now. Don't give it a first. QR is okay. QR. Can you see QR? So can I write instead of QR equal to QM plus MR equal to QP square plus PR square. I'll write same. Now can you open it? QM square plus MR square plus 2QM MR equal to QP square plus PR square. That's fine. Now I'll go on some other work. Can you see QM square? Here it is PQ square. This is PQ square. So I'll do something. 2QM plus 2QM and MR is equal to QP square minus QM square plus PR square minus MR square. Now let's look QP square minus QM square equal to PM square. Why it is so? Because this is also right angle triangle. No? The right angle triangle, it means use PGT. PQ square equal to PM square plus NQ square. So PQ square minus QM square equal to PM square. So instead of these two, what I am going to use? 2QM into MR equal to, instead of these two, I can write PM square and PR square minus, MR square I should write here. Now read PR square minus MR square. Same. PR square minus MR square equal to again PM square. So write here PM square. So Pm square 2m square, and it is 2qm mr, and cancel and get qm mr equal to Pm square. That's the answer. That's the answer. You have got it. It was actually a little bit tough. I have taught you. Okay. Let me tell you one second method here. Let me rub this out from here. Already it is good method. Still, I have one more method which I want to tell you. Look at it. To show this one. Now, first of all, I go on a small triangle PMQ. PMQ, where PQ square equal to PGT, PM square plus MQ square 1. In triangle PMR, we have a PR square is equal to PM square plus MR square. Equation number 2. So here you have got it. I need PM square. I need PM square. Okay, I'll get it. No worry about it. So third one I want to take. In the triangle QPR, I have a Q and QR square is equal to QP plus PR. Now I have taken all the equations. I have taken all the right angle triangle, and we have got this particular thing. I need a PM square equal to QM into MR. So we have a 3 equations. You can understand now. I'll move by this QM QR. Can you see QR? I can write QM plus MR. So instead of that QR, I will write QM plus MR square equal to QP square plus PR square. Same it is. I just open it. Equal to this one. Now can you put the value? Can you see? PQ square I have somewhere, PR square I have somewhere. So PQ square and QPR square I have values. So I think we should put these values there at by 1 and 2. Look at it. Easy method I am telling you. QM square MR square equal to 2QM MR. This is a it is a plus sign equal to QP square equal to PM square plus MQ square plus PR square equal to PM square plus MR square. Now can you see that this MR square cancel, QM square cancel, and 2QM MR equal to PM twice PM square. 2 and 2 cancel. So QM into MR equal to PM square. We have got the answer. So we have one more method. It was both are actually same. No worry. Have to think little bit. Otherwise, the rest are okay. So question number 2. It was from the exercise. Now I will tell you question number 3rd. Okay, question number 3rd, which I am going to tell you. Already I have told you that question number 2nd, which already I have explained right now. So it is your job. Question 1 and 3rd are same. But what I will tell you, I will not use a Pythagoras theorem, because this question based on the previous concept also, which is gonna easy to you, so that do by this method. Question number 3rd says, we have a picture, just aside it is given, it is B, A, B, this is C, 90. Question says, ABD is a right angle triangle with angle A equal to 90 degree. C is point on BD such that AC perpendicular to BD, and to show, first I am telling you only, AB square equal to BC into BD. The third one you will make by your own, AD square equal to BD into CD. So third one you will make, guys. Second already taught you that it is the same as the previous one. First, AB square equal to BC into CD, BC into BD, and the third one is AD square equal to BD into CD. Or both are same actually. So first I am doing. Look at how we can go with the method which I feel actually easy. I am telling you this. I won't use the Pythagoras theorem. Even it is in the exercise where the Pythagoras theorem is continuing, but I won't use here the PGT. So it is never be told in the question that do by the PGT. Whatever the method which is easy to you, you can use this and get your answer. So okay. So I start with some special thing which I will make specially and separately. Can you see this triangle BCA and BAD? Now can you catch, this is 90, this is 90, and B is a common angle. So you know that angle similarity. In triangle I will write in triangle ABC and BAD. What equals are? Angle B equal to angle B common angle. Angle C equal to angle A 90 degree. So by angle similarity, these two 90, these two are equal. By angle similarity, triangles are similar. So give the proper name. A, now 90 degree, now acute angle. A equal to D. Why? Because there is no symbol here. C is equal to A, B is equal to B. Definitely A will be equal to D. So D, then right angle, so DA, and then acute angle B. This is a way of writing. So when two triangles are similar, what will happen? Corresponding sides will be proportional. So what corresponding side you are having? AC upon DA. Does AC and DA is coming here? No. So don't write. CB upon AB, yes it is. And AB upon DB. You know, it's very simple to identify the corresponding side when you write a good triangles, correct triangles. By labeling, it should be correct. Then you can do the cross multiplication. CB into DB is equal to AB into AB square. You have got the answer. Can you see? BCBD, AB square, and that's correct. So I think it's gonna easy to you. I don't think it's a tough one. So guys, question number third we have completed. Third one, same as that time you will take this triangle and whole triangle as similar condition. Okay. Now more questions I'll take. Question number 4 is very easy. 4 is very easy question. Triangle ABC is an isosceles triangle with C as a right angle triangle. Triangle ABC is a right isosceles triangle with AC equal to BC and angle C is 90 degree. You know, it is given that it is right angle C and it is isosceles. One should know that these two are same. If it is an isosceles triangle, hypotenuse cannot be equal to with any side, any other side. It is actually longest one. So these two are equal because it is isosceles and angle C is 90. It is given to show AB square equal to 2AC square. So very easy it is in triangle ABC by PGT. AB square equal to AC square plus BC square. AB square equal to AC square plus BC square. I need 2AC square. I will write, since AC equal to BC, it is given AC equal to BC because both sides are equal. So I will put AC square is AC square, but instead of BC I will write AC. So AC and AC is gonna be 2 ACs. This is hence done. So hope student is good enough of the class, today's class. Tomorrow we'll have some more question of the exercise and we'll finish the chapter. Thank you.